way to the left side, you'll see you have off. If you click it up one time, you're going to go to DC. Yeah, you can always tell DC on your meter because it's going to have a straight line. DC, your meter, you get that close there. The second markup is AC. You'll see it's in a wave. AC is not as direct as DC. It's very smooth. And AC runs things like general illumination on your pinball playfield. But let's start back at DC. First step. And the best thing you can test is a AA battery. These are used in your pinball machine. 3 of them are used for memory. We've got 2 leads on our meter. We have a black and a red. We refer to the black one as the ground side, at least I do. And we refer to the red one as the power side. Chris is going to go ahead and put this on, and you're going to read, without the glare, but that is 1.6. Most AA batteries will read 1.5, but these are Panasonic's exceptionally great batteries. So there's a great way to use DC. You need 3 of these to keep most of your memory in your pinball machines. If you add all 3 of those voltages together, 1.6 or 1.5 times 3 is 4.5 to 4.8, then you know your batteries are good. Another useful tip on DC is we're going to pull up the power playfield here and show you where ground is at. We told you that the black lead is for ground. If your meters keep beeping, just hit the range button or the NCB button and it should dissipate. I brought this meter along because I like the 5 functions that it had. Anybody got dead batteries not working? To use it. So basically I tell them to take the black lead and stick it on the ground. A ground can be found almost anywhere on the game. Typically, when I have the playfield up, I always go for the ground braid. If you point the ground braid there, Master Chris. Ah, way ahead of me. Nice finger. On most of these machines, in order to test voltage at coils, you need to have the door closed. So if you're testing something and looking for DC on a coil or a switch, you might need to have the door closed. So let's go ahead and find a coil, usually the flipper coil or something close where you can get your fat hand in there. So we've got our black ground lead on the ground, and then we've touched our red positive lead. And are we getting any reading on our meter, Chris? 65.
Question, watch what happens.
Watch this.
Why do you think that is? So the coil is nothing more than a hose, right? There's going to be power at both lugs of the coil, unless the wire windings are broken somewhere within the coil. So it doesn't really matter which coil lug you touch.
And for us, it really isn't so important that you're finding what the voltage is. You're trying to find that there's voltage there. Because typically, when a coil isn't working, we want to know that there's at least power going to the coil. I never worry much about what the rating is, if it's a 50 volt or a 12 volt. I just want to know that there's some power going there. If there isn't, then I know I might have a broken wire somewhere, or I'll begin to look someplace else. And we could even show them something on a switch, Chris?
Here's another ground stuff. I've got it. It's a black lead on the side rail of the game.
Yeah, sometimes it's hard to bend over to the game, so if you use the side rail in the game, you can also find ground. And you'll see that we have more DC voltage there.
Let's come back to that when we talk about resistance.
Great. move your meter up one to the wavy line that says V, that will be AC voltage. And the most prevalent spot you're going to find this is on the general illumination of the game, or few components on the boards.
So here I'm measuring between the green and the white wire with the green trace. This is AC. General illumination voltage is nominally about 6 volts. We've got about 4.75 here. So that tells me that I've got power coming out of this power driver board that's good for general illumination. You can sometimes test AC against the ground reference or the side rail. I never trust that because you never really know what you're getting. So if you're testing AC voltage, you have to test between the AC source and the AC return. Where I got a better, my probes are making better contact now. I've got 5.6 volts.
Just like to remind everybody, most of these electrical devices inside the game will only give you a tingle or a jolt when you touch them. However, some voltage levels, like the dot matrix controller, are very powerful and high enough to be lethal in certain situations. So, they always tell you to turn the game off, but it's kind of hard to test anything when you have the game off. So what you want to be mindful of is not to have a lot of extra stuff laying around, screwdrivers in your hand. Try to keep your area as clean as possible. You could drop a screwdriver and short out a switch matrix, and that means you have to send your board off to get fixed and more problems. The biggest part about having a meter is actually using it. Don't be afraid of it. I mean, you're going to have to test things. You're going to get things wrong many times. I've gotten my meters many times wrong, and then finally I get it right. So just keep testing and testing and testing, and eventually it will come to you, just like riding a bike. Next, we're going to move on to resistance test. If you flip your meter up one more time, and we'll have Chris and Mike show you that on the meter. This has the nice omega sign. I don't use resistance except for one thing, and that is finding different values of coils. I buy and sell a lot of games, and I get games that have burnt coils on them or a lug is busted, and I know the number on the coil because it's clearly written, but I know I can't use the coil. But I have a whole pile of used coils in a drawer, and I want to put one of those coils on. So I get one that's similar in size. I spend 5 minutes, put it on the game, and then I find out that the VUK I just put that on, or the slingshot I put it on, doesn't have enough power. So I wanted to find out a way to test coils to see how powerful they were. So in the resistance test, or omega test, you can literally take your black and red leads and touch them to the two legs of the coil. And you're going to get a reading. That one is 10.4. So if that one was bad on your game and had a busted lug or was fried and you wanted to find something similar to it, you could find another coil of similar size. Of course, you can't grab a big giant coil to use in a small coil position. So he's going to get the next coil that's close in size. We're going to test that. But we're lucky because these two coils only have 2 lugs. And we're not lucky because Chris has sausage hands, so hard to believe he fixes as many boards as he does without getting burned. So that one is 3.9. Our other one was 1.0. So they are pretty far away from strength. The higher the number, the stronger it being. So the yellow coil would not be a good replacement for the green. The other way around.
The lower the resistance, the stronger the coil is. So this coil here, this is 23 gauge wire, 800 turns on the wire. And it's going to have lower resistance than this 26 gauge wire that's coiled around this the bobbin 1200 times. Kind of makes intuitive sense. The lower resistance coil is going to be a stronger coil. So this bad boy here, use that in a vertical up kicker. This one here you might use on a kick-out bowl like in the Twilight Zone in the ball lock area.
If you move your meter up one more to the symbol with the sound, that is supposed to be a speaker with sound coming out of it. This is the most valuable one to me, and this is the one usually most people know, is a continuity test. This is a must for checking fuses. Rule number 1, you cannot check a fuse in line. I have so many service calls I run on where I have people check fuses. They pull out their multimeter, check the fuse in line, tell me it's good. I drive out 2.5 hours, go out there, pull the fuse out, it's bad. I replace a 10-cent fuse, $60 for the service call, and a lot of my time that I shouldn't have spent. Continuity is also good for testing wires in your pinball machine. When you have a certain strain of lights that aren't working, a lot of wires break in the middle because they have a wire tie on them or they've gotten stretched. When you touch the red and black lead together, if you have it in that mode, you should hear a tone. Now what's nice about this meter is it does have a tone, so you don't have to be looking at your meter to tell if you have continuity or not. Good thing about continuity is you can put the leads on either side, it doesn't matter. As long as the wire's not broken, you'll be good to go. And when we get done here, if anybody is really confused, we're going to have some time. We'll have stuff up here on the table you can test, you can come up and run through some stuff. If you flip it up one more time, we're going to go to the diode test. I don't know why they call it the diode test, I'm a layman. I never check diodes. The only way to check a diode is to actually cut it out of the line and then check it. By the time you cut it, check it, find it's good and resolder it back in, you could have bought a 10-cent or 7-cent, 3-cent diode and just soldered the darn thing back in. A diode is a component used on switches and coils. It is a component that allows current to flow through the device in one direction. When these go bad, you'll get variations. You might get a flipper fluttering back and forth.
So Chuck, I've got a bridge rectifier up here, which is nothing more than 4 diodes all ganged together. And I'm measuring one diode that's inside this bridge rectifier. If the diode measures anywhere between about 0.4 and 0.7, then that diode's good. Like Chuck said, the diode will carry current only in a single direction, so I'm going to reverse the leads now. You can see the meter says 0.462 right now. I'm going to reverse these leads, and hopefully this is a good bridge, and it will be null. So that means that that diode out of the 4 that are in this bridge is a good diode.
Tell them what the bridge rectifier is used for, Chris.
Bridge rectifier is used to, as it says in the name, rectify AC voltage into DC voltage. AC voltage, for you guys who remember your math, is a sine wave. The rectifier takes the AC voltage and it full wave rectifies it so that it looks like mountains. And then further on, these filter caps on this WPC power driver board that will filter that cap so that the DC voltage is more or less constant. The bridge rectifiers on the WPC power driver board, there's several of them on here. There's 1, 2, 3. There's 2 underneath this heatsink here. So if your WPC game is resetting, what's the first thing you do?
Check line volt.
You go to PinWiki and you follow the discipline process. There's an 11-step process. About the 10th one is to check the bridges and the capacitors. So, Mike, can you bring the camera up here? We're going to check the bridges on this board. So, somebody's done some work on this board.
That was a loaner from Beauregard. I think
yeah.
that's a board he's going to be fixing for someone.
And I've done so many of these that I know where all the bridges are on this thing. I say that now.
Right here.
I'm looking at it upside down. Okay, here's one I like to check. Can you hold that for me, Tom? Okay. So to check a bridge rectifier, you take the black lead and you place it on the oddball leg. Okay. So there's 4 legs to this bridge rectifier, and it's the one on the other side of the board here. This one here I call the oddball leg because it's out of a square configuration. So if this was up here, it would be a square. So I'm going to put the black lead on the oddball leg. I'm going to put the red lead on the flanking legs. for that. There, that's measuring 0.491, so that's a good leg. I'm going to go to the other side, and that's going to measure. You have to take this board back to Robbie. I'm not sure this bridge is good. Yeah. Over here. Oh, I know what I was doing. Okay, sorry. 0.459 on that one. 0.458 here. That's good. And then I'm going to move the red lead to the opposite side, and the black on the flanking. So we got 0.462. Then we got 0.463. So that bridge tests good. Now, a bridge can test good, yet it can fail under load. So, but testing it like we did just now with your digital multimeter is a good first step.
Let's go ahead and leave it up there for the transistor test. I hate it when they call it the diode test because I use this for the transistor test. If you ever have a coil that's locked on, or you have a lamp that's locked on, you get that burning smell, you have the plastic melted underneath the flasher, typically means that the transistor went bad and it locked on. And for years, once a transistor locked on, I'd have to pull the board, send it to somebody that knew more than I did, and have it fixed. And the going rate for these boards is $90, and they only fix what's wrong with them. And it just seemed a shame for a $1 transistor that I couldn't test these things myself. So if you look at your quick meter guide handout there, the transistor test, that's a typical image of a transistor. This basically turns off and on and allows coils to power up or lamps to power up. These are also tested just like bridge rectifiers. They test in between 0.40 and 0.70. And it took me a while to catch this. I actually would just pull boards out once they were out, and I would just run through and just check different transistors. Transistors will test differently in games between Gottlieb, Williams, and some of the newer Stern or Sega stuff. But if you know you only have one bad transistor on your game, something's locked on, you have a host of other transistors to check. There's 40 other transistors on that board. Check some good ones, find out what they read, how they read, and then move down the line, and you can find what is bad. Are you able to see that?
So with your meter, if you're testing one and it's bad, you'll hear something like this. Well, this meter doesn't buzz, but you can see it's showing 0 resistance. And I'm testing between the tab on this transistor and the center leg.
Yeah, what you'll do is you'll take the black lead and you'll put it on the tab of the transistor or the middle leg. And this is on a Williams board, which I think most of us collect, gains between 89 and 94, 95. You take the black lead, put it on the tab or the middle leg, and then you move the red from left to the right, and it should test between 0.4 and 0.7.
Anything else and that transistor is bad and you should replace it. Or you should send it to your favorite board repair guy.
Yeah, board repair guys love that. But honestly, for a simple desoldering tool and a very cheap soldering gun, that area of the board is very robust. It's very hard to mess much stuff up there. I mean, you can, I have. But after you replace one or two, you get real confident in doing it. And I almost look forward to when a 12's lock on so I can replace a transistor and save myself some money. So those are the 5 things we want to teach you about your meter. I mean, there isn't a whole lot else that you really need to know to fix a pinball machine. That's why I love this meter. It has the 5 functions right in order. It's not very confusing. You can run right up from DC, AC, resistance, continuity test, and then your diode test. And inside the diode test, we can check diodes, and most importantly, transistors. Anybody have any questions?
Is that clear? Yes, sir.
Do you like the auto ranging meters or the you separate the profile one that goes?
I personally like the auto ranging meters. There's less to fool with. And I hate it when somebody calls me up and I say, well, get your meter out. And I say, measure DC resistance and or DC voltage. And they'll say, well, it's got a 20 and a 200. Go to Radio Shack and get a meter.
This is an auto ranging meter here. You'll also notice on this meter, it has a NVC on it. And this is so you can actually get close to the wire without actually touching it, and you can get some readings with it, which most of the stuff isn't very high current underneath the play field, so I usually don't mess with it. Yes?
You know why you get a false continuity reading?
Sorry, what was that, sir?
Why you get a false reading on a fuse that's in the holder
Oh, yeah.
that's bad and it tests good?
That's a really good question. So it's because there's an alternate path where you're finding ground. So imagine if you had a battery, and a wire, and a light bulb, and a fuse, and then the wire went around to the other side of the battery. The fuse is blown, but if you put your probes on each side of that fuse holder, the meter's going to find that backdoor circuit around through the battery and back to it. That actually happened to me the other day. I was looking at a Gottlieb System 80 and I was testing fuses. They all tested good. And I pulled them out and I put my meter on the fuse clips with no fuse in there and I got a tone. Would have been a great example right here. Next question. Yes, sir.
Can you use a meter to test a resistor as well?
Yeah, absolutely. The omega sign on there is resistance. You said resistance of
I'm talking about like a resistor that brings the voltage down. You know, you have the ceramic, I call them ceramic resistors.
It's broke, put your own batteries in.
Yeah. I call them sand resistors.
Yeah.
Like, they're in the 18-volt flash lamp circuit for games like F14. So sure, you put that on resistance reading, and those are usually 3 or 4 ohm resistors, so just put it on there. You can test those in circuit anytime. So that's a very, very handy thing to be able to do. Resistance readings, most of the time, I gave it to see if the coil is any good. And if I measure the resistance of a coil and it's down to, say, 2 ohms, that's not a good thing. Make sense to everybody?
I got a question. What's the best way to check large capacitors?
Large capacitors?
Is there any good way?
Well, you won't be able to do it with this meter. But there is a device for checking large capacitors. It's called an ESR tester. It's probably overkill for pinball machines. You know, this thing here, it's got the 15,000 microfarad caps. If they're bulky, they're suspect. Just get rid of them anyway. I use mine all the time to test the smaller ones. I got a Fluke 179, and you can measure up to, I think, 10,000 microfarads on that. So I test them. Sometimes they test good, and the game still doesn't work, so I don't know.
Capacitor tester. It doesn't give you a number in here, which will be only in your plate.
Chuck, you got anything else?
I really don't. I mean, the biggest thing I'd say with a meter is don't be afraid to use it. I mean, you got to get it out, you got to play with it. You're not going to learn this stuff overnight. You're going to get a shock, you're going to mess something up, but I tell you, get it out, use it on your boards. And if anybody wants any one-on-one, we're probably going to have another half an hour left. So you can come up here and do some transistor testing. We can talk more about anything you need. So appreciate you coming out. I didn't expect as many people to be here. I'd have bought more free flashlights, but hey, that's not